Hey, okay. More square roots. During the last lesson, we only focused on square roots of perfect square numbers. So today we're going to look to see what happens when you take the square root of a number that's not one of these perfect squares. Okay, so title is Simplifying Square Roots. Simplifying. So we're not solving them because they're not perfect squares. Before I show you what I mean, we do want to get some vocabulary written down. Okay, so I'm going to just do a little diagram here. So go ahead and draw yourself a little square root right there. Okay, and really what this is called is the radical. So the symbol part of it, it's called the radical. So go ahead and label that, please. Radical. And in my class, we're going to be primarily focused on square roots. So most of them will not have a number here because the 2 in a square root is just implied. So there's that secret 2 that's not really needed. But in the future, you might have a cube root or a 10th root or something crazy, okay? So I do want you to put a little n right here. N is for the nth root. So if it was a 4, it would be a 4th root. If it was 10, it'd be a 10th root. So you're going to call that the root. Another name for a root is an index. I'm not going to quiz you on index, but you do need to know that whatever number's there is the root, okay? And if there is no number where the root is, then it's a 2. It's a square root, okay? And then whatever number, variable, whatever, we're just going to call it x, whatever is underneath the radical, there is a name for it. It is called the radicand. Radicand. This vocabulary word, radical and radicand, we're going to use that a lot, okay? Radical is the symbol, radicand is whatever's below it, okay? So let's just do a quick little review of last lesson, see how much you remember. Square root of 100 is 10, because 10 squared is 100, okay? Square root of 49 is 7, because 7 squared, 7 times 7 is 49. Okay. Square root of 90. Square root of 90. 90 was not part of our perfect square list. It's not in there. So let me show you what happens when you take the square root of 90 on a calculator. Here we go. Square root, that's my square root symbol. Square root of 90, boom. Whoa. Okay, we're gonna write down some of those digits. So right next to square root of 90 in your notebook, we're gonna do a little squiggly equal sign. That means approximate. It's approximately 9.48683. We'll call that good, okay? Obviously there's more, and honestly, like your calculator stops at a certain point. It's not gonna do any more digits than that. So this is not an exact answer. And as mathematicians, we don't like non-exact answers. We need to know the exact value. So when the radicand is not a perfect square, you have to simplify it. You have to simplify the square root so that we do get a whole, not a whole, a non-decimal value, okay? So that's what I'm going to be teaching you today. So I do want you to write yourself 2 little things, 2 little notes. You're going to point to the 100 and the 49 And just remind yourself that 149 are perfect squares. Okay. So since they're perfect squares, that means that the square roots of them are whole numbers. Cool for them, right? But this 90 is not a perfect square. So you're going to write yourself this little note. If the radicand, so we're using some vocabulary, radicand is the number underneath the radical. If the radicand is not a perfect square, we must simplify it. Okay, that's what I'm teaching you how to do today, how to simplify a square root of a number that's not a perfect square. Okay, so we're going to write the steps. The steps might be a little until you actually try it, but I do want these steps written down so you can refer back to them when you get stuck. Okay, so here are your steps on how to simplify square roots of non-perfect squares. Step 1. So we're going to write all the steps and then we'll actually do the steps. Step 1 is you're going to find the largest perfect square that the radicand can divide by. Find the largest perfect square that the radicand can divide by. Step 2, we'll make sure it makes sense later. Step 2, break down. And what I mean by break down is you could say rewrite. Break down / rewrite the radicand using the perfect square number. Okay, so we rewrite it using that perfect square you found in step 1. Step 3, double check. Double check each radicand. You're going to do a little ... What I mean by double check is you're going to see if they can divide by any perfect squares. Okay. Step 4. This is your last step. Simplify the square roots of perfect squares. Perfect squares. Simplify the square roots of perfect squares and leave the rest under the radical. Okay, pause that, get caught up, play it when you're ready. Okay, let's make some sense of these steps. So it talks a lot about perfect squares. We're going to have to use this list of perfect squares right here. So here's my suggestion. On the next page in the margin right here, I suggest, because I'm going to do this, I suggest to make yourself a list of perfect squares. Okay, at least get the first 12, if not more in there. Okay, so like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. You could go on if you want. 69. Oh, 196. I don't know. 196. I gotta check myself. Doesn't sound right. 14 times 14. Oh, that's right. 196. I'll do one more. 15 times 15. I think is 2. Yep, 225. Okay. I'm going to call that good. So pause if needed. Fill it in. This is our quick little reference. Okay. So directions to this section is simplify. Number 1. Okay, so in our calculator, we did the square root of 90 and we've got the decimal approximation. We want the exact value, but we do want to simplify it. Just like fractions, you always simplify fractions. And your teachers make you simplify fractions. Same thing goes with square roots. You have to simplify them. So square root of 90, I'm going to show you how to simplify it using these steps. Step 1, find the largest perfect square that the radicand can divide by. We have to find the largest perfect square that 90 can divide by. So if you're not good with multiplication facts in your head, you're going to need a calculator on your phone or whatever. Now, 90, obviously numbers bigger than 90 are not going to divide by it, right? 90 is not going to divide by 100 because it's larger. You could, I hope you know that 90 is not divisible by 81, but let's pretend that you just weren't good at multiplication facts. You would basically go through your list. 90 divided by 81. If you get a decimal, we don't want it. Go to your next one. 90 divided by 64. Decimal. Nope. 90 divided by 49. Nope. 90 divided by 36. Nope. 90 divided by, and you would keep going and divide these perfect squares until you found one at the whole number. Okay. Now, secretly, I'm hoping that a lot of you knew that 9 does go into 90, and 9 is one of your perfect squares. So we found that 9 was the largest perfect square. So now we're going to do step 2. We're going to break down or rewrite, however you want to say it, rewrite the radicand using that perfect square number. So another way to write 90 using that perfect square would be 9 times 10. Do you agree with that? 9 times 10 is still 90. I'm just writing it a different way, okay? Now there is a property of radicals. Go ahead and add it right here. There's a property that says the square root of a times b is equivalent to the square root of a times the square root of b, meaning you can break those two things apart. So I can break apart negative the square root of 9 times 10 into the square root of 9 times the square root of 10. Okay, so this is me breaking down or rewriting square root of 90 using that largest perfect square. Okay, let's see our next step. Double check each radicand. See if they can divide by any perfect squares. So 9 is a perfect square, so we don't have to check that one, but we do want to check to see that this other guy can't divide any further. So we want to see if any of these lower numbers, 9, 4, 1, can fit into 10 nicely. 10 divided by 9, decimal. 10 divided by 4, decimal. 10 divided by 1 is 10. But dividing by 1 doesn't really do anything. So if 1 is the only number, the only perfect square then that this 10 can divide by, then we're done with that. We can't go further, okay? So we double check our radicands. Oops, double check our radicands. And then we have one last thing to do. It says simplify the square roots of perfect squares and leave the rest under the radical. So we can simplify the square root of our perfect square. What is the square root of 9? It's 3. And then I'm going to leave the rest under the radical, right? So this is now 3 times the square root of 10. Now, a lot of times in math, we like to shove things together and we just know it's multiplication. And that's true for this. This is just going to be 3 root 10, 3 times the square root of 10. Okay, so square root of 90 is the same thing as 10 or 3 times the square root of 10. And I can prove it to you in my calculator. I can show you one more time the square root of 90, the decimal approximation. And I can also plug this in, 3 times the square root of 10, and I still get that ugly decimal. Okay, so those are equivalent, they're the same thing. Let's try another one. Square root of 84. 84 is not a perfect square, so we do have to simplify it down using the perfect squares. So 84. All of these numbers are lower than it, so potentially they could fit inside of it. So if you're not good with multiplication skills, you might go, okay, 84 divided by 81, decimal. 84 divided by 64, decimal, and you could keep going, okay? So I'm questioning 16. I don't know what it is in my head, but I'm going to see if 16 fits in there. It doesn't, but I bet you 4 does. 4 definitely goes in 80, so it has to go in 84. So 84 divided by 4 is 21. So 4 definitely fits into 84. So I'm going to rewrite this as the square root of 4 times 21. I can break those apart like we did earlier. That's the same thing as the square root of 4 times the square root of 21. And this is step 3, where you check to see if you can break it down any further. So 21 is not a perfect square, but can it divide by any of the perfect squares? 21 divided by 16? No. 21 divided by 9? No. 21 is only divisible by 3 and 7, which are not perfect squares. So we have done all we can do. Now we just simplify further. The square root of 4 is 2. So we have 2 times the square root of 21, which we can kind of shove it together to look like this. 2 root 21. 2 times the square root of 21. Okay. Hoping this is making some sense. So number 3. So we're going to solve this next one 2 different ways, okay? We're going to solve it, we're going to say or. We're going to solve it 2 different ways. Square root of 80. So in our notes, it says find the largest perfect square. You'll have some teachers that go, no, you don't have to find the largest. And that's true. You don't have to find the largest perfect square, but you do need to find a perfect square that fits into it. So like, for example, I'm just going to tell you right now, 80 is divisible by 16, which is a perfect square. It's also divisible by 4 though. So if I was solving this off the top of my head, I might not realize that 16 goes into it. And maybe I don't want to do the calculator thing where I test all of them. But some of you know deep down in your heart, some of you know that 4 definitely goes into it. 4 times 20 makes 80, right? So you could split this up into the square root of 4 times the square root of 20, okay? And here's the issue though. If you don't find the largest perfect square that fits into it, then you gotta really make sure that you simplify this other number down, okay? Square root of 20, 20 is divisible by a perfect square. 20 is divisible by 4, right? So what this means is you would break down square root of 20 into the square root of 4 times the square root of 5. And then I drop this down, so we're left with this. Square root of 4 times the square root of 4 times the square root of 5. Okay, well, square root of 4 is 2. Square root of 4 is 2. Square root of 5, I can't go down any further, so I leave it under the radical. You have one last thing you can do. 2 times 2. 2 times 2 is 4. So our final answer is 4 times the square root of 5. Okay, so if you know immediately that one of the perfect square fits into it and you want to just go for it, then go for it. But what that means is you're going to have to really make sure that that other number is broken down all the way. Okay, or you could go with the largest perfect square. The largest perfect square that fits into 80 is 16, and I'll prove it to you. 80 divided by 16 is 5. Yes. So you can break this down into the square root of 16 times the square root of 5, because 16 times 5 is 80. And then you would just need to simplify real quick. Square root of 16 is 4. So my final answer is 4 times the square root of 5. So finding the largest perfect square, and not just any perfect square, is going to save you some additional steps. Okay, something to think about. We're going to do 2 more. Number 4. Okay, this one, you have a negative, but it's not under the radical, it's in front. And then under the radical, you have a 72. So square root of 72. Okay, this little negative right next to it, it's being multiplied. So it's a secret what? It's a secret -1. And it's timesing by the square root of 72. 72 is not a perfect square, so we do have to break it down using the perfect squares. So pause the video, find which perfect square, what's the largest perfect square that fits into it, and hit play when you found it. So 72, if you're checking in a calculator, obviously anything higher than it can't go into it. So you could check 64, 49, 36 does go into 72 nicely. 36 times 2. So you can break this apart into the square root of 36 times the square root of 2. Okay. Hit, try to simplify this further. Okay, and hit play when you're ready. So square root of 36 is 6. So I'm just going to drop down everything else. Okay, square root of 2, I can't break down that further, break that down any further, so I just leave it under the radical. But now I just simply multiply these up. -1 times 6 is -6. I leave the 2 under the radical, so my final answer is -6 times the square root of 2. Okay. Last one. Square root of 26. I would like you to find what the largest perfect square that 26 can divide by is. Okay. Find the largest perfect square that fits into 26 and hit play when you found it. Okay. So 26. So I would go up to like maybe 16. 26 divided by 16, decimal. 26 divided by 9, decimal. 26 divided by 4, decimal. Obviously, it can divide by 1, but that doesn't do anything cool. So what does this mean? None of the perfect squares fit into 26. You know what this means? It means that square root of 26 can't be simplified any further. That's it. That's the answer. Square root of 26. Okay, so you're gonna make yourself a cute little note right here. Here's the note. The note says 26 is not divisible by any perfect squares. So square root of 26 is already simplified. Okay, it's already in simplest form. So if this was a test question, you would literally, you could just go like this. Final answer. You can't simplify it any further than that. That's all it is. Okay, so I am going to get you some practice. Biggest thing is just finding the largest perfect square that fits into that radicand. Okay, and then rewriting it from there. So practice on Delta, and we will most definitely practice in Zoom. This does take some practice. Okay, see you guys. Thanks for watching.